Hello and welcome back to ACER Explained. I'm going through the Section 3 portion of the ACER Practice Question booklet, and in this video I'm going through Unit 16. So in Unit 16 we have questions 44 to 47. As usual, I'm going to be identifying some prereq knowledge, some reasoning skills that you can use, as well as the Bootcamp resources that would help with this unit. So let's start off by looking at Unit 16. We're given a table as well as a figure and some text as well. And it's basically telling us, well, the first paragraph is telling us that there's certain mutants for the bacteria Salmonella. And these mutants, they've tried growing them on different growth plates that are supplemented with different kind of intermediate metabolites. And so if you look at table 1, you can see that when there's no supplementation, none of them can grow. So the negatives indicate that there's a failure to grow. So all of them need at least one thing to be supplemented. So that tells us that there's something wrong in their system, in the bacteria system, when it comes to metabolizing a particular metabolite. Okay, so looking at question 44. Question 44 is asking where would indole most likely build up? So in which mutant would indole most likely build up? Okay, and indole in the table is indicated by a lowercase I at the top here. So let me just, yep, there we go. So it's saying which one of these would likely have an indole buildup. So when would you have a buildup of indole is when would you have that? It's when it's unable to be broken down into another metabolite. Okay, so when this process is interrupted, you'd have a buildup of indole here. Okay, so over here, looking to back at our table, we have indole is supplemented here. It's supplemented here, and it's supplemented here, okay? And all of these three can grow. Oh, sorry, these three. Oh, sorry, these ones. Try 3, try 8, and try 2 and 4 can grow when you have indole supplemented. However, you have this group here that cannot grow even when indole is supplemented. So that kind of tells us that indole is likely unable to be broken down by these bacteria or these mutants here. And therefore it would lead to a buildup. So you do kind of, it would be handy for you to have some of that prereq knowledge on enzymes and pathways and metabolic pathways, because that kind of gives you an idea of this kind of experiment. But you can also go ahead and use the process of elimination and use kind of your pattern recognition skills. Your question is asking about this chemical here. And so if you're looking at your 4 options, you have try 1, which is option A over here. You have try 2, which is option B. Try 3, which is option C. And then option D, which is try 8. Out of these, the only one that has a negative is the one that's try 1. So you could literally just use a process of elimination and figure out the question that way. But either way, the answer is A. So for this question, you didn't really need any prerequisite knowledge, but with the kind of enzymes sort of activity and the metabolic pathways, it's helpful to be familiar with that. So we do have the bridging course on or the content in action on cells and cellular metabolism that you can look at in the bootcamp. The reasoning skills that were used here were the process of elimination, as well as just pattern recognition and being able to decipher graphs and tables and diagrams. So we have the reasoning skills course, as well as the acceleration class on diagrams and visual stimuli, on graphs, and on tables as well. Question 45 is asking about the figure, and this is a proposed figure for a potential pathway that explains the information that we're given in table 1. So we're being asked what the most valid statement is here. So first of all, let's look at our figure. we have step 1, that's that's creating anthralic acid. Then we have step 2, which is changing anthralic acid to IgP. Then we have step 3, which is converting IgP into indole. And it's one of the steps that's helping convert IgP into tryptophan as well. And then step 4 is that conversion of indole and IgP into tryptophan. Okay, so that's step 4. And these are both catalyzed by serine. Okay, so first of all, let's look at our try 1, try 6, and try 7 in our table. The reason I'm looking at this one first is because it's kind of the most simple. It only grows when supplemented with tryptophan. It doesn't grow when it's supplemented by anything else. So it only grows when there's tryptophan there. Okay, so it doesn't matter if you give it I, doesn't matter if you give it IgP, doesn't matter if you give it A. It's not going to complete the metabolic pathway, and it's not going to survive. You need to have tryptophan. So that kind of gives us a good indication that tryptophan is the most downstream step, because, for example, if you give it A and these upstream steps are not working, if you give it IgP and this upstream step is not working, and if you give it I and this upstream step is not working, it's not going to grow. But if you give it T, if there was another step here, for example, IgP, if there was another step here, then if you give it tryptophan, there's a potential that it might not grow, because this step has a potential to be disrupted. But if this is the most downstream, then it's going to grow on tryptophan supplemented medium. Any bacteria that has the mutation in this pathway is going to grow in tryptophan supplemented media. And that's correct. As you can see, all of our mutants can grow in tryptophan supplemented media. Okay, so that indicates to us that tryptophan is the most downstream, which is consistent with this figure here. Okay, so now let's look at the other options. So, well, let's look at indole. Okay, I'll choose a bit of a brighter blue for this. Okay, looking at indole. So we have only one that can't grow in indole, and that's the one, that's our try 1, try 6, and try 7. So in this kind of category of mutants, we can assume that all of these upstream steps, so steps 1 to 4, are disrupted, and you need to supplement it directly with the final step, or the final product, for growth to occur. Then we have our next most commonly growing supplement. So out of the supplements that are remaining, we have the most growth on the indole supplementation. Okay, so for example, with try 3, we have growth when you supplement it with tryptophan. We also have growth when you supplement it with indole, but we don't have any growth if we supplement it with A or IgP. So that indicates that there's an issue with steps 1 and 2. Okay, there's an issue with steps 1 and 2. And it makes sense that indole it could be the second most, well, it could be the step that's prior to the tryptophan, as is indicated by this figure here. There's nothing that's contraindicating it. You know, this doesn't prove that this is the correct figure, but there's nothing contraindicating it so far. Okay, there's nothing contradicting table 1 so far. Now let's look at try 8. So try 8, it grows if you supplement it with IgP, if you supplement it with I, if you supplement it with T, or if you supplement it with A. So it's basically telling you that all of these steps here are working, except potentially step 1. Because this is a mutant, there's probably something wrong. And when you don't give it any supplement, so if you don't give it A, it doesn't grow. So that means that it's probably a defect in step 1. And so we can kind of see that A and IgP are probably higher up compared to I. Basically what we're trying to see is that does the information on the table does the figure contradict anything that's given on the table, right? Then finally we look at try 2 and try 4, and this one grows when you give it IgP, when you give it I and when you give it T, but it doesn't grow when you give it A. And so that means that for try 2 and try 4, there's probably something happening here with step 2. Okay? And looking at the figure, this all makes sense with the positives and the negatives, like where the mutants are growing and not growing. It all makes sense with the figure. So it could be correct because it doesn't contradict table 1. This reasoning here, it could be correct because a single enzyme catalyzes steps 3 and 4. We're not given any information about a catalyst, a common catalyst in our information. So technically, this doesn't tell us anything, right? Because we're not told that this has to be true. So we can eliminate this. Then we can eliminate option C because we've just said that it is sufficiently consistent with table 1. And then finally, we have this enzyme thing happening again. So it's incorrect because a single enzyme could not catalyze steps 3 and 4. We have nothing that says that it could not catalyze steps 3 and 4. If we had some sort of information that was telling us that we need more than one enzyme, then we'd be able to prove that this option is correct. But we don't have anything that's telling us that, so this is eliminated as well. And the correct answer is A. For this question, the main thing that you need to be able to do is interpret a flow chart. It does help if you have some enzyme background or some background on metabolism, but the process of elimination and interpreting flowcharts is enough. And so the reasoning skills course and the acceleration classes that I've mentioned here cover that. And the content in action, cells and cellular metabolism, might help just be a little bit more familiar with these kind of processes. This question is asking us to look at the figure once again, and it's saying that the defect in try 3 could directly impact only which step. Okay, so the key word here is directly. And so let's look at try 3. Try 3, when you put it in nil, it doesn't grow. When you put it in tryptophan, it does grow. So I'm going to put a little dash here. It does grow. When you put it in indole, it does grow. In A, it doesn't grow. And in IGP, it doesn't grow as well. Okay, so now I'm just going to quickly draw out that pathway that we were discussing earlier. So we have step 1 leading to anthralic acid. Then going to IGP, we have step 2. Then going to indole and tryptophan. So we have step 3 here. They've given a bit of a dotted line like that. And then this step here, this is step 4. Okay? So when you supplement this bacteria with T, it grows. Okay? So that's pretty obvious. All of our bacteria, all of our mutants will grow when you give them the final metabolite. So that's fine. When you give it I, it also grows, which means that step 4 must be functioning. Okay? So we can eliminate option D because step 4 must be functioning. Then when you give it IGP, it doesn't grow. There's no growth there. So that means step 3 could be affected. And then we have the final step here, which is A. So when you give it A, it doesn't grow as well. So technically, if you were looking at this information about A itself, you could say that step 2 is also impacted in this mutant. However, if step 2 isn't working, but you supplement IGP anyways, steps 3 and 4 should still be able to work. And so you would still see growth in IGP. But because you're not seeing any growth in IGP, it means that step 3 is the one that's impacted. Because even if you give it anything, even if step 2 is working, even if you give it anything prior to IGP, if step 3 is not working, then you'll see this pattern of a lack of growth with IGP and A that's seen in try 3. And so that's why the answer for this one is C. For this question, I don't think you need any previous knowledge, to be honest, because it's just all about looking at the figure. You don't even need to match it. Well, you don't need to verify it against the table because you're kind of assuming that the table is correct here and you're assuming that the figure is correct, sorry. So all you need to do is interpret the flowchart and look at the steps and think critically in that sense and use your reasoning skills there. So with your pattern recognition and process of elimination also. And the reasoning skills course is really great for this, of course. Then we also have our acceleration classes that are dedicated to diagrams and visual stimuli, as well as the classes on graphs and tables as well. So those can help with kind of showing you or helping you practice how to be able to extract this information from diagrams and flowcharts more easily. Now, this final question in the unit, this is pretty much simply prerequisite knowledge. So it's just saying that this Salmonella typhimurium is a typical bacteria, and so it would have what? So it's basically asking what would bacteria normally have. Now, you should know that bacteria do not have membrane-bound organelles because they are prokaryotic. However, they do have a cell wall, so you can already kind of see that option A is correct. And they don't reproduce by binary fission only. They can also undergo some special kinds of sexual reproduction as well, or like gene crossing. So that's also something that you would know if you have this prerequisite knowledge on basic microbiology. And so obviously if B is incorrect, then we can't say D is correct as well. And so, yeah, the answer is A for this one. This question was pretty much prerequisite knowledge only. So if you didn't know this, I would have just guessed and moved on. And so you just had to have a bit of a knowledge on prokaryotes and eukaryotes. And so the content and action that could help with this is the cells and cellular metabolism one on the Bootcamp. That brings us to the end of Unit 16. Thank you for watching. As always, like, share, and subscribe for more GAMSAT help. We love your feedback. And we have our Instagram at ThankFlipGamSat, as well as our podcast, ThankFlipGamSat Nurses Doing GAMSAT. If you want to hear more from us, that's always there for you. All right, I'll see you in the next one.